Now I want to take a look at our second to last question. And this is a very simple one about function definitions. Just like class definitions are executable code, so are function definitions. What happens when I define a function? Let's take a look. When you see def f pass, this is executable code in Python. There is no hoisting like there is in JavaScript. There is no compiling this to bytecode and then storing that bytecode off to the side like there is in C. These are two lines of code that are actually executed. This line of code is not executed in the sense that you run that line of code. It's parsed and it's compiled, but this line of code is executed. This is why you can define functions in loops. You can define functions within functions. And of course, when you define this function, you wouldn't run the body, because what if the body, deleted something? That would make no sense when you create the function. However, the header line of this function is executable code. This will print out something. This header line is executed. It's just the body of this that has its bytecode created and then attached to whatever this header line tells you are the name of this function and the default arguments. Which means if this header line includes a variable, includes some data that is mutable data, this line here creates one instance of that mutable data and stores it in your underscore defaults. One unique instance of this mutable data, which means if we call this function multiple times without passing in this value and getting the default, every time we call this function, we're getting the exact same object. It's not creating this new thing at runtime. It's creating the exact same object live for you. Sorry, it's returning the exact same object every single time because this is executable code, which means if we mutate this every time we call this function, even though if you're a C++ programmer, C programmer, or Java programmer, you might say, oh, this creates a brand new list, 1, 2, 3, every single time. No, it uses and reuses the exact same list, 1, 2, 3. This is the mutable default argument problem. And the solution to the mutable default argument problem is just move the creation of this data into a scope where it will not be evaluated when the function is created, or it'll only be evaluated when the function is called. Just move it from the header line into the body of the function using a sentinel value like this. Now, people, for whatever reason, seem extremely confused about mutable default arguments, and I don't know why, because it seems like a very natural consequence of every single line of Python code is executable code, and it's run from top to bottom, including the header lines of functions. If I said x equals 1, 2, 3, or default x equals 1, 2, 3, default x, this makes sense that this thing is just going to be reusing this. That's all is happening in the mutable default arguments, which is why I am extraordinarily skeptical of proposed PEPs that try and remove this mutable default argument problem, because they are just too limited in what they can do, and I just don't think it's that interesting of a problem. Because if you really want to have fresh defaults, you can write your own code with a simple decorator that allows you to supply defaults, and you do stuff that the PEPs don't allow you to do. For example, taking the state of all the other arguments that were passed in to compute your default based off of the state of those arguments. Something like this is completely reasonable to do. But our conclusion is all Python code is executable up to and including function headers. Thus, mutable default arguments are a very natural consequence of the Python execution model, and you can understand them in that consequence.